Hello and welcome to episode 3 of Software Explained Simply. We're continuing with our programming language fundamental theme, and we're continuing with conditional logic and control flow. I wanted this episode and the previous one to really be one because they're still kind of in the same theme, but I didn't want them to get too long, so I broke this one out. And it's probably good because this is a somewhat meatier concept, so if you get confused or lost, take your time and make sure you practice a lot so you can get these fundamentals down. So we're going to be talking about 3 things today, and that is comparison operators, Boolean operators, and then checking for presence, or does something exist? So to start out, the reason we have conditional logic is because there are many times when we're programming that we need to choose between running different blocks of code. So there are common scenarios like, do we have a logged in user or are we dealing with a guest? Is the user on a paid account or a trial account? Or is the user an admin or not? And so we want to run a different code block based on if that statement is true or not. Now, at the simplest form, we have comparisons. And comparisons are usually with simple types of data. So these would be things like comparing numbers. Now, if we remember back to the previous episode, we covered something called assignment. So we had this statement, x equals 3, and we said that this is taking the value of 3 and storing it in a variable called x. And here these examples are in Ruby. But across almost every programming language, this is generally true. One equal sign represents taking a value and storing it in a variable on the left-hand side. Now for a comparison, we use a double equal sign. And double equals represents an equality check and not an assignment. So the equality check, let's say our first line was run and we stored the value of 3 in the variable x. The equality check will say, is x, or the value of x, equal to 3? And in this case, that would be true because x is stored to the value of 3. Likewise, if we said, is x equal to 4, we would expect that to be false because 3 does not equal 4. Now, what about this case where x is 3 and we say, is x equal to the string 3 or the string with the character 3? Now, in Ruby, this is false. In some languages, this is not true, and in some languages, that statement is true. Like JavaScript, for example, it's kind of quirky and has some weird edge cases. But in JavaScript, that would actually evaluate to true. So whatever language of choice you've chosen, make sure you know how that works. But in Ruby, the number 3 and the string 3 are not equal. We can do comparisons like you might find in a math class. So if we have x equal to 3, we could say, is x greater than 10? And we would expect that to be false. 3 is not greater than 10. And then likewise, we could also say, is x less than 5? Which would be true because 3 is less than 5. Now, one maybe edge case you don't think about is if we ask if a number is greater than itself. So if x is 3, and then we ask, is x greater than 3 or is 3 greater than 3? That is not true because 3 is not bigger than 3, it's equal to 3. And so just like in math, you would have your less than or equal to operator. And similarly, you have a less than or equal to operator. So is x less than or equal to 3 or is x greater than or equal to 3 would evaluate to true. Okay, let's talk about control flow and let's see how we can use some of those comparison operators. So we want to be able to change what our program does based on statements that evaluate to true or false. And the most basic construct we have for doing that is an if statement. And almost every major programming language has an if statement. It's just a core component of programming. It allows the code to make decisions based on what happened. So an if statement basically looks like this. We use the if keyword, we have some kind of condition, and then in between the starting if keyword and however it ends. In Ruby, we use the keyword end. All the stuff between that we call a block. So it's a chunk of code, a block of code. And if the condition of the if statement is true, it will run that block. If the if statement condition is not true, it will just skip past the if statement. So let's look at some examples of that. So here we have x equal to 3 in this if statement. If x is greater than 1, assign the value of 10 to x. So based on this little snippet of code, what would you expect x to be at the end of this code? And if you want to pause your video and think about it, you can do that. Okay, you might expect x to be equal to 10, and you would be correct. X is equal to 3, so when we hit the if statement, 3 is greater than 1, so the code inside of the if statement block is run, and the value of x is changed to be 10. So at the end of that snippet, the value of x is 10. Similarly, if we take the opposite scenario, if x is 3 and our if statement says if x is greater than 100, set the value to 10, x would still be 3 at the end of the code snippet because 3 is not bigger than 100, so the code within the if statement is skipped, and it skips to the end and continues on. And skips to the end as in it skips to the keyword end and moves on, just to be clear. So here's another example. Let's say you had a voting application you were making. You might have a statement in there similar to if the age is greater than or equal to 18, the person can vote. And you would have code that allows them to vote, whatever that looks like. Now, you want to do something if they can vote, but you also want to do something if they can't. And so there is another very common keyword every language has called else. And so if the if conditional is true, it will run that block. But if it's not true, it will run the else block. So it's a catch-all that no matter what else is true, it's going to run the else if you specify an else block. You can actually specify this even further. Most languages have what is called an else if keyword. And so it still executes sequentially, but it gives you more options. So you can try a couple things, and then if all those things don't work, then you can have your generic else block to handle whatever you need to handle. So in this example, our color is equal to the string red, and our if statement says, if the color is equal to blue, we'll run the blue code. Else, if the color is equal to green, we'll do the green code. And then if both of those are not true and both of those checks fail, then we'll do else, and we'll handle that case. So here it still executes sequentially, so we're going to check if it's blue. If that fails, we're going to check if it's green. And if that fails, then we'll run the else. But if the color was blue, we'd run the blue code and then leave the if statement. Or if the color was green, we'd get to the green statement, that would become true, and then we would run the green code and we would skip the else. So there's only one path that's chosen based on the conditionals. And just to kind of show you how similar these are between languages, here's Ruby on the left and then JavaScript on the right. And you can see that the if statements are basically identical. JavaScript uses curly braces to denote what blocks are. And you also have to put the parentheses around the conditional, but it's the same basic structure. Okay, let's shift gears a little bit and talk about Boolean operators. Now, Boolean operators, there's really three main ones, and the first one is called AND. And an AND operator will only return true if all parts of a statement are true. So let's say you were trying to model a statement in your application similar to this. If the temperature is below 32 degrees Fahrenheit and there is precipitation falling from the sky, then it is snowing. So here it's only snowing if the temperature is below 32 and there is precipitation. If only one of those things are true, then it's not snowing. You have to have both. So if we look at an example AND statement, here we have 3 is equal to 3, which is true, and 10 is greater than 5, which is also true, then the statement is true. Because both pieces are true, the entire and statement evaluates to true. To give a negative example, here we have the same start, so 3 equals to 3, or 3 equal 3, which is true. So the first part is true. And 5 is greater than 10, which is not true. So we have a true and a false, which evaluates to false, because every piece has to be true for an and statement to be true. On the kind of opposite side, we have or statements. And or statements return true if there are any part of the statement that returns true. So you could say, in our example from before, if the temperature is below 32 degrees Fahrenheit, or there is precipitation falling from the sky, then the weather is bad. So here it's either or. If it's below 32, it's really cold, so the weather's bad. Or if it's raining, that's not good, so the weather is also bad. And so an example of an or statement might be like this. If 3 is equal to 3, or 10 is greater than 5, then it evaluates to true. Here 3 is equal to 3, and 10 is greater than 5. So we have two trues. So since either part has to be true, that evaluates to true. Here we have in the second statement 3 equal to 3 or 5 greater than 10. Now 5 is not greater than 10, but because the first part of the statement is true, the entire statement evaluates to true because it's an or. The final operator we're going to look at is the not or negation operator. It's represented by an exclamation point, or you'll sometimes hear this called a bang. And so the not operator negates or flips or makes this statement opposite. So you can use it as a comparison by saying, is x not equal to 3? And just kind of a point you need to know, not true evaluates to false, which makes sense. If something is not true, it is false. And not false or bang false evaluates to true, which makes sense. If something is not false, then it is true. So if we go back to our is it snowing example real quick, we might model that as an if statement, kind of like this. So if the temperature is below 32 and there is precipitation, it is snowing. So we need both of those things. We need below 32 and we need the precipitation. If we evaluated that statement using variables, we'll set both of our variables to true. And then if we evaluate that statement, we can plug in our variable values. So temperature below 32 and there's precipitation. So we get true and true, which evaluates to true. Here, it's true because in an and statement, you have to have all pieces equal to true. Now, so that's our statement for if it's snowing. Our statement for if it is not snowing would be to negate that statement. So we can wrap the entire statement with parentheses and use the not operator. So it is not snowing if the temperature is below 32 and there's precipitation is not true. And that's kind of a weird way to say that, and we'll look at a way to phrase that a little better in a second. But if we just use our same example here our temperature below 32 is equal to true, but our precipitation variable is going to be false. So if we evaluate this, it is not snowing statement. Same thing as last time, we'll plug in our variables. So we'll have not the result of true and false. So an and statement, every piece has to be true. So true and false is equal to false. And so our statement becomes not false, or the negation of false, which is true. So if the temperature is below 32 and the precipitation is false, there's no precipitation, then it is not snowing. So that checks out. Now, it's kind of weird to speak the not statements out loud sometimes. And so there's a way to rewrite not statements that sometimes makes it a little easier to read. And that's using something called De Morgan's law, which says that not the result of A and B is equal to not A or not B. So here's our statement, which reads kind of funny. not temperature below 32 and there is precipitation, like that doesn't make a lot of sense if you just read it and say it in English. It's hard to wrap your mind around what that means. So we can change that using De Morgan's law, and we can say if the temperature is not below 32 or there is not precipitation, then it's not snowing. And so they're both functionally equivalent, but to me the bottom one reads more like I would think in English. But they're both the same, so whichever one works best for you. So just to evaluate our new transform statement, we'll do the same exercise. Temperature below 32 is true. There's precipitation is false. We have not temperature below 32 or not there is precipitation. Plug in our variables. We get not true or not false. Do the negation, which gives us false or true. And because this is an or statement, if any piece of the statement is true, the entire statement is true. So it evaluates to true. So to recap our Boolean operators, we have and, which is true if all pieces of the statement are true. We have or, which is true if any of the pieces of the statement are true. And then we have not, which negates a statement or value. And just to kind of give you a little crazy example, you can combine and build out these statements as far and as long as you want. And so you can chain together nots, ors, ands. You can do it between 5 things, 10 things, 1 thing, and sky's the limit. Okay, so let's talk about presents. There are a few places when you're doing programming where you'd want to check using a simple comparison. So you'd want to see if their age is above 18, for example, maybe. But in most cases, you want to know the presence questions. You want to know, does this thing exist or not? Does this user exist? Is this user logged in? Do I have a user that is logged in? Does this user have any friends? Do they have any posts? Do they have any outdated bills that need to be paid? And so you check for the existence of things quite a bit in programming. So let's look at a very simple example, and then we'll kind of play around with it in more practical terms. But let's say we're trying to look at the question, does the user have any friends? And our friends here are represented by an array that we talked about last time. And our friends are just an array containing 2 strings, so Alice and Bob. And what we really want here is we want a way to use this friends array in an if statement conditional. So we want to be able to say, if the user has friends, let's do things with those friends. Otherwise, maybe let's do something else. And so to do that, I'm going to switch over to some practical examples. We'll kind of just play around with this for a second. So here I have, on the left, I just have any text file. This file is called test.rb, so it's just a Ruby file. And then over here on the right, I can just run this file so we can see the output. So real quick, a good way to kind of play with programs is to just print stuff out. So in Ruby, you can say puts, and then you can give it something to print out. So I could give it a string. I could tell it to print a number, and if I run this, it will just print those values out. So we'll use this print statement to see where our program goes as we play with it. So for example, if I said x is equal to 3, if x is greater than 1, I'll print out in here. And if I run this, because 3 is greater than 1, I should expect this to see the words in here, which I do. Conversely, if I say is x greater than 1,000, run it again, I don't see any output because the if statement was not run. Okay, so let's go back to our friends example. So let's say we have friends, and it's an array that contains the string Alice and Bob. What we want to do is we want to be able to say, like, if friends exist, and then we want to print stuff in here. Yes, we have friends, or no, we don't have friends. Okay, so how do we convert this friends thing into some type of Boolean condition or statement? Now, there's a couple ways you can do this. For arrays specifically, we could reference the length property that we looked at in the previous lesson. So one way you could say is if the friend's length is greater than 0, then we have friends. And if we run that, we can see that we have friends printed out here. Now this works pretty well, but there's some edge cases here that we need to look at. For example, let's say instead of having this array, I'll just go ahead and comment this out. A reminder that anything that's commented is not run in a program, so I could put garbage in here, and this is not going to be run. So it's just kind of hiding it for a second. But let's say I make friends an empty array, so there's nothing in here. Here I run this, and it says we don't have friends. So that's great. That we have no friends, so it ran our else statement, which is what we wanted. Now let's say that friends was nil. So not that we don't have any, that there are 0 friends, but that the data does not exist for whatever reason. If we run this now, we get this nice little error message, which says undefined method length for nil class. And that's Ruby speak for you tried to ask for the length of something that doesn't exist. Remembering here that nil or null in most other languages means the absence of a value or no value. So you're trying to check the length of something that doesn't exist, and Ruby is giving us an error saying you can't do that. So what you'll see in a lot of languages is they will prepend doing something with your data with this. They will say if friends and friends.length is greater than 0 as the statement. So if we run this now, it says we don't have any friends. And what we did here is we added this if friends piece and it together. And this friends right here is saying if this value exists, then continue on with this statement. So some languages like Ruby have what is called short circuiting. So it evaluates something, for example, this part of the statement. It sees that it's an and it sees that this first part is not true. Like we don't have friends, the friends are nil, so it doesn't even run this back half. It just leaves it. And so what that allows us to do is to have this statement that is safe to run, because if we don't have friends, it will short circuit and just move on. And you'll see this pattern a lot. You'll see this in JavaScript quite a bit as well. Now, another option we could do, just comment that out real quick. You also see a lot of things like if bang friends, you see this in JavaScript quite a bit. And this is basically saying if friends does not exist. So if this could also be written as if friends equal nil. So you see this in a lot of languages where they're saying like, do we have this data? If not, we want to do this. Otherwise, we're going to do something else. Now, if you look at, let's go ahead and get rid of this stuff. If we go back to our friends equal to an empty array scenario, we say if friends, we have friends, we don't have friends. If we run this, it says that we have friends, which is kind of misleading because we don't have anything in here. We have an empty array. And that's kind of a landmine for us to step on later because it's doing something that is not intuitive. We would expect it to see that this is empty and see that we don't have friends. But the if statement is trying to make what is called a truthy value out of this data. And so it sees an empty array and it says an empty array is not nothing, it's just an empty array. So that is evaluates to true in the language's mind. And so this isn't really great for us. Like we don't want to always have to, specify the length, guarding it like this and such or whatever. We really want this to be intuitive. We want to say like, if our friends exist, like the data is there and there's stuff in here, we actually have friends. We want to do that. And in the Ruby language itself, there's not really a great way to do that, but many frameworks and things built on top of that will provide nice helpers for you. So for example, I'm inside of a Rails project here. And so not that you would ever want to do it this way, but just for the sake of example, if I require Rails will give me this handy helper method called present. And present is like a fancy equality check, and it does what we want it to do. It handles cases like this, where it's like, yes, there is an array there, but there's nothing in there. And so if we run this now using present, it will say we don't have any friends, which we expect because what we want is this. We want real data in here. And this present method has some extra logic in there to say like, okay, we have an array, but is there anything in there? If not, then it's not really present. It doesn't really exist in the way we want. And so here, if we add people, we can see that we have friends. So based on the language or the framework you're using, there may be helper things like present that will help you get around some of these weird edge cases. It's just dependent on what you're using. Now, there is weird stuff that happens with this kind of stuff. So let me just open like a plain Ruby console. So here I just have like a basic Ruby console. So if we say 1 is equal to 1, that evaluates to true. High equal to high, evaluates to true. We can get into kind of weird things that really don't come up that often, but just something to keep in the back of your head if you ever start seeing weird results. We can do things like 2 and 3, which returns 3, which is kind of weird. Or, we can do like 2 and high, which returns high. These aren't cases that really come up a ton, but you can get into weird edge cases as you deal with equality. And it's just something you have to kind of know your language, know your framework, how it works. The last thing I want to show you, just to kind of show you some of the other quirks. Here I have just the Google homepage, and I'm using the console tab of the inspector. So, you can run, like I said in the last episode, you can run JavaScript here. So one kind of funny thing is if you say, is 3 equal to 3, that's true. But if is 3 equal to the string 3, which is true in JavaScript, it's not in Ruby. It's just one of those weird things you have to know. Just something to know. But as you can see, equality statements in JavaScript are almost exactly the same as in Ruby, aside from this one weird edge case. Okay, so I hope that was helpful to kind of play with it and see how those things work. So let's recap real quick. We looked at a couple Boolean operators and how to check for equality, this being different from assignment. Looked at how to do some basic control flow using if or else if or else. And we looked at how we check if things exist or if there are presence of those things. And then we looked at how truthiness can get kind of weird depending upon what your language is. So for homework this time, got a couple things you can play with. Obviously practice using the stuff you saw here. So do equality checks, comparison, play with and or and not. If you want to play with that weird statement or the long statement that I put in there, that's there, and you can assign your own values or just use the ones I have there. X is false, Y is true, Z is false. You can practice modeling sentences using Boolean statements. So like our is it snowing example. So if it's a Sunday and the hours before 12, then the restaurant serves brunch. And so you might say, okay, is Sunday is true, the hour is 9, and then use your print statements, whatever that is in your language. So in Ruby, it's puts, and just to show you, in JavaScript, it's console.log, just print stuff. So use your print statements in whatever language you have and play with those. Practice using if, else, if, and else statements. And then kind of a bonus question or bonus homework, there's a There's something called a case statement. Sometimes it's called select. And those are a kind of a different way of writing if statements, but they function the same way. They have conditions and return values for those. So you can play with that. And then play around with truthiness. And you don't have to get real far in the weird stuff, but knowing, if I have an array or I have a hash, does it exist? What does existence mean? Like in the case of an empty array or an empty hash, how does that work? So that's it for this episode. The next one, I think I'm going to cover methods and functions, which is getting into the real stuff now. So I hope you've been enjoying this. If you have questions or comments, let me know below, or I'm at John Mosesman about everywhere. So I'll see you next time. Thanks for watching.